Welcome back, class 9, to the online chemistry classes. Today we are going to start the fourth chapter, that is atomic structure and chemical bonding. In this chapter we are going to study about what is an atom, how it is different from an element, and what is the modern atomic theory, how it is different from the Dalton's atomic theory. Then we will also study about the discovery of electrons, protons, neutrons, which are known as the fundamental particles or the subatomic particles that makes an atom. Further, we will study about the chemical bonding. What are the two different types of chemical bonding, that is electrovalent bond or the ionic bond and the covalent bond. We have to study about the compounds which are formed by them, like ionic compounds are formed by ionic bond, and electrovalent or the ionic compounds, covalent compounds are the one which contain covalent bonding inside them. We have to read their characteristics also. So starting from the atomic structure, from earliest times, man has always wondered that what is the ultimate nature of matter. You know that matter is anything that has mass and occupies space. So man wanted to know what is matter and what is it made up of. And this led to find out all the constituents of the substances. When scientists started exploring matter, that is finding out what matter is, they realized that matter is further divided into smaller particles which are known as subatomic particles. Now, the smallest particle of an element that maintains its chemical identity in all the physical and chemical changes is called an atom. So what is atom? How to define? Atom is a Greek word which means indivisible, that cannot be divided. And the search for finding the characteristics of this smallest particle led to the modern atomic theory. Then we have to study about Dalton, John Dalton in the year 1766, and he died in 1844. John Dalton is called the father. John Dalton is known as the father of modern atomic theory. Father of modern atomic theory. Okay, so this scientist John Dalton is called the father of modern atomic theory, and it is different from the atomic theory which is known now, because he proposed the atomic theory 200 years back in the year 1808. That time chemistry was not well developed, and after that many changes took place due to discovery of the subatomic particles like electrons, protons and neutrons. So although many changes has occurred in that Dalton's atomic theory, still whatever he discovered, some of the points are still valid till today in the modern atomic theory also. And that's why he is called the father of modern theory. And we'll compare the Dalton's theory with that of modern atomic theory. In a tabular form is given, that is, one side we have the Dalton's theory, the other side, when we compare with the modern theory, modern atomic theory, what differences they hold, or what are the differences present between the modern atomic theory, you can write atomic here, modern atomic theory and Dalton's atomic theory. What are some of the points which are different between both of them? Dalton's atomic theory says that all matter is made up of small particles called atoms. So matter is made of atoms. Matter is made of small particles called atoms. But here in modern atomic theory, it says that an element is made up of extremely small particles called atoms. Element is made up of atoms, extremely small particles called atoms. So here it says that element is made up of atoms. Here it says matter is made up of atoms. First difference is this one only. One says matter, the other one says element. The second difference is atoms are indivisible and indestructible. So Dalton theory says atom is indivisible. We cannot divide an atom. And indestructible. We cannot destroy it. Indestructible. But this one, the modern theory says atom can be divided, it can be destroyed. So atom is divisible. We can write here atom is divisible. And we can also destroy it during the nuclear fission reaction. Then third point is atom is the smallest particle of an element. Dalton's atomic theory says atom is the smallest particle of an element. Particle of an element. Whereas the modern theory says that atom consists of smaller particles which are known as electrons, protons and neutrons. Atom is made up of electrons, protons and neutrons. They are called fundamental particles. Protons, neutrons. P and N I have written, not the full words. Electrons, protons and neutrons. N for neutrons. Okay. Then the fourth point or the fourth difference between Dalton theory and modern atomic theory is all atoms are similar in all respect. All atoms are similar. R I have not written. All atoms are similar in all respect. Whereas the modern theory says that atoms of an element may not be similar. That is, they may have different masses like isotopes. Atoms of same element may be different. Like example I will give you. The isotopes of hydrogen example are number 1, 1H1, that is protium, deuterium and tritium. 3 isotopes of hydrogen are there. So all of them belong to the same element hydrogen, but all of them are different, that is they are not similar. So this one says the modern atomic theory that atoms of same element may be different, but Dalton's theory says atoms of the same element they are similar in all respect. And the last fifth point is atoms take part in a chemical reaction and the number of kinds of atoms are constant in a compound. Atoms take part in chemical reactions. And the next point is the number and kinds of atoms are constant in a compound, whereas the modern atomic theory says that atoms do take part in chemical reactions, but the numbers and kinds of atoms are constant in a given compound. Okay, so this point, the fifth point, is almost similar in both of them. The relative number and kinds of atoms are constant in a given compound. Here also, the relative numbers and kinds of atoms are constant in a given compound. So fifth point is almost similar, if not the differences we can count. Now next, you have to learn these differences between Dalton's theory and modern atomic theory. After that, the next point or the syllabus which we have is definition of an element. You have already read in lower classes also what is an element. Element is the smallest particle. We can define element is a pure substance. Pure substance are of two types, elements and compounds. In class 8 you had studied, which are made up of same kind of atoms. So element is a pure substance that contains only one kind of particles. These particles are atoms or molecules. So particles can be atoms also or molecules also. So if I say that one element of hydrogen, then I have to write it as, if I write a single H, that represents only one atom of hydrogen. Okay? So we have to write H2O2 because two atoms, they are present together in one molecule of hydrogen, in one molecule of oxygen. So what is the definition of an element? Element is a pure substance. In chemistry you have to learn what is the meaning of pure substance. Pure substance are those which are made up of same kinds of atoms or molecules. So, element is a pure substance which is made up of only one kind of particles. Made up of only one kind of particles. Called atoms or molecules. These particles are called atoms or molecules. Okay, so if I say like this one, H2. H2 means one molecule of hydrogen, in which there are two atoms of hydrogen. One molecule of hydrogen. Okay, so how many elements are there? You know, carbon, sulfur, iron, lead, gold, hydrogen, oxygen, nitrogen are some examples of elements, whereas iron, gold contains single atoms. In iron, if you see the formula of iron, symbol is Fe. Only one atom of iron is there. One atom of iron. Fe means iron. Okay, this is the symbol of iron. And similarly, in the gold also, gold means Au is the symbol of gold. Only one atom of gold is present. But if you take one element of hydrogen, atoms like in which two or more atoms combine together, like in hydrogen and oxygen, it consists of molecules in which there are two atoms. If you take oxygen also, one molecule of oxygen is O2. So there are two atoms in one molecule of oxygen. Okay. So what is the difference between atoms and molecules? Atoms, there are a single atom, like only one element is there. In atom means a single will be there. Molecule means in which there will be two or more atoms which are combined together in it. Hydrogen and oxygen consists of molecules which has two atoms combined together. Now you know that the elements which are known to us, total number of elements are 118 elements are known. Okay, this is the total number of elements that we know we have in our periodic table. Now out of these 118 elements, some of the elements are the one which is found naturally. We are not making it, it's already present in the Earth's crust. This number is 92. They are called the naturally occurring elements. Okay, the remaining elements, so if you subtract 118 minus 92, 8 minus 2 is 6, 26 elements. So these 26 elements which are not found naturally, it is made by man or synthesized in the lab, they are called artificial elements. Artificial elements or man-made elements also you can write, and they are known as naturally occurring elements. Okay. Now next we have to read about the definition of an atom. Okay, next we have to study about definition of an atom. So how to define an atom? Atom is the smallest particle of an element. It is a part of an element. Like gold is the element. So gold is made up of gold atoms. Iron is the element. Iron is made up of iron atoms. So smallest particle of an element. The smallest particle of an element that may or may not have independent existence. Independent existence. Okay, means atom is a part of an element which is the smallest part of that element, and that atom can either remain freely, that is, it can remain independent, or it may not remain independent also. Examples are, for example, atoms of iron, copper, silver or gold, they can exist freely. Iron, copper, silver, gold, they can exist freely. Freely means only a single atom can remain independently. But there are some other atoms who cannot remain independently. So two atoms or more than two combine together in that atoms, like in oxygen O2, in hydrogen H2, in nitrogen. So these are the atoms in which a single atom cannot exist independent. That's why they form a group to become stable. So they can exist as H2O2 N2. They are not freely. It means they have no independent existence. They are remaining together to remain stable. Now next we have to study about the structure of an atom. You know that an atom consists of, if you draw the diagram of atomic structure, in the center we have a positively charged spherical body which is known as nucleus. What is this part called? It is known as nucleus. Nucleus is the center of the cell. Just like in animal cell, plant cell, nucleus is there in the center. Here also in the center we have a nucleus. Then the nucleus contains two subatomic particles which are protons and neutrons. Protons are positively charged, neutrons have no charge, and around this central positively charged nucleus there are certain paths, circular path on which electrons will revolve. They are the electrons. Electrons are negatively charged, so electrons will revolve around the nucleus in a fixed path, and this path is known as orbit or shell. Orbit or SHELL. Why they are called energy shell or shell? Because each and every electron, each and every path has a particular energy level associated with them. They are designated or written by the names, like the first one, the first cell is called K, the second one is called L, third cell is called M. Different paths are there. Then the fourth one is called N, K, L, M, N. First cell is called K, second L, third M, fourth one is called N. So the research which is done by different scientists, many scientists have worked together to find out the structure of atom, like Goldstein, it was Thomson, Rutherford, Chadwick, Bohr. They have established that atoms are made up of smaller particles, and these particles are electrons, protons, neutrons. These three particles are called fundamental particles. Okay, what are they known as? They are known as fundamental particles, also known as, the other name of this fundamental particle is subatomic particles. Subatomic particles. So if asked what are the subatomic particles, you will say the smaller parts of an atom, or those particles which makes an atom, are called subatomic particles. Like an atom is made up of still smaller parts which are known as electrons, protons and neutrons. Electrons are negatively charged particles, protons are positively charged particles, neutrons are neutral charged. And protons and neutrons are present inside the nucleus of the atom, whereas the electrons revolve around the nucleus in a definite path or orbit, which is also known as shell. Okay. Now discovery of electrons. Next we have to study who discovered this electron and how it was discovered. Okay, and what are some of the characteristics of electrons. So next topic that we have to do is discovery of electrons. You know that electrons are negatively charged particles that revolve around the nucleus of an atom in a fixed path or orbit, and these electrons, let's start. Discovery of electrons. Okay. So next topic is discovery of electrons. Now if it is asked, name the scientist who discovered electrons, answer is J.J. Thomson. J.J. Thomson is a scientist who is associated with the discovery of electrons. P is not there, Thomson only. Thomson in which year? In the year 1897. 1897. He discovered the presence of negatively charged particles in an atom, and he called them as electrons. Now what was his experiment? With the anode rays. J.J. Thomson's experiment was with the cathode rays. And for his experiment, what he had done, I will just draw the diagram and explain it. There is a glass tube. This is a glass tube. Okay, it has a side tube also attached to it. and this glass tube, which is sealed from all sides, it is known as a discharge tube. So what is discharge tube? A specially designed glass tube having a side tube, and in this discharge tube there are two metallic, means made up of metal strips, which are known as electrodes. So there are two metal strips which are called electrodes. Okay, what are they known as? They are called electrodes. I'll just write it, E-L-E-C-T-R-O-D-E-S. Electrodes. Okay, so electrode is connected to the negative terminal. This is connected to the negative terminal of a battery. Here we can see the battery there. This one has the negative terminal of the battery, minus side. This terminal or this electrode, which is connected to the negative terminal of the battery, is known as cathode. What is it called? The name is cathode. C-A-T-H-O-D-E, cathode. Whereas this one is connected, the other terminal is connected to a positive terminal of the battery, and it is known as, this is the positive side of the battery. So this is known as, this particular electrode is called anode. Anode and cathode, two different electrodes are there, which are connected to the two different ends of a battery. This one is the battery for the current or for the electricity, because from the battery only the charges will be flowing. Now inside this discharge tube you can see the other electrode, the air inside the discharge tube, whatever air is present inside, it is thrown outside or pumped outside with the help of this side tube, which is connected to a pump, P-U-M-P, pump. The pump is the one which will suck all the air outside, vacuum. Okay, it means this discharge tube will be free of air. There will be no air present inside it. Now, what was the experiment that he had done? Gases are generally very poor conductors of heat and electricity. They are poor conductor of electricity. So Thomson showed that when a gas is taken in a discharge tube and electrical discharge is passed through it, when a current is passed through it at a very low pressure, that is 10 to the power minus 4 atmospheric pressure, the pressure becomes so less, that is about 0.01 millimeter. The high electrode potential, that is 10,000 volts, the current which is pumped inside it, 10,000 volts, okay, 10,000 volts, a faint green color, a faint green glow is seen near the glass walls of the discharge tube opposite of cathode. Means here you will find that the certain rays will be coming outside from this particular cathode. They are called the cathode rays. Okay, certain rays are being produced and it is going towards the anode because they are negatively charged. So faint green glow is seen near the glass walls of the discharge tube. Okay, glowing glass wall, you can see this particular glass wall will be glowing. Glowing glass wall, faint green color is shown here in this discharge tube. Now, he also observed that some particles or rays are being emitted from this cathode side, which moves towards the anode side. So he called them as cathode rays. The rays which are produced from cathode, he called them as cathode rays, R-A-Y-S. What is a ray? Ray means like this, a line which has a particular direction, like the sun ray. Okay, it starts from one particular place and goes in a particular direction. And these rays are going in a straight line. So there are some characteristics which we'll study about these cathode rays one by one. So he called them as cathode rays. And what are the properties of cathode rays? So once again, this experiment I will explain. J.J. Thomson, Thomson, in the year 1897, carried out an experiment to explain the process of discovery of electrons, in which he took a discharge tube. This is a discharge tube. What is a discharge tube? It is a specially designed glass tube that has a side tube. This is a side tube, you can see, and it contains side tube in it, it contains two electrodes, that is metallic strips present in it. These metallic strips act as electrode. Now the next point is, one of the electrode is connected to the negative terminal of the battery. This one is the battery. This is the negative part of the battery, that is the positive part. So this particular electrode which is connected to the negative terminal of the battery is called cathode. Similarly, the other end of the discharge tube, the electrode which is connected to the positive end of the battery is called anode. So anode and cathode are the name given to the two electrodes. Okay. Now, what is the experiment here done? All the air has been removed outside from the discharge tube with the help of the pump, so that it becomes vacuum, and we know that gases are poor conductors of electricity. So when a current of 10,000 volt was pumped into this discharge tube through this battery, of course, at a temperature of very low temperature of 10 to the power minus 4 atmospheric pressure, we found that the opposite side of this cathode, means towards this end of the discharge tube, there was faint, what is the color shown? Faint green glow was observed in this part of the discharge tube. And we also found that certain rays were coming outside from the cathode and moving towards the anode, and he called them as cathode rays. So this much was the experiment. Now what are the properties of cathode rays? These cathode rays which are generated or produced from the cathode electrode, they have certain properties. Number one, they have plenty of kinetic energy. Kinetic energy means energy due to motion is called kinetic energy. Like K is equal to half mva square, you know. So kinetic energy is present, and whatever objects are present in between, in the path of this cathode rays, they will be heated. Okay. So cathode ray has kinetic energy and heat the objects on which they fall. Number two, cathode ray travels in a straight line. You can see they are not traveling like this in zigzag way. They travel straight way, all the cathode rays. And if any object is placed here, suppose I have placed an object here in the middle of this cathode rays, then it will produce a shadow of this object. Yes, the shadow will be also formed, just like when we stand in the sunlight, our shadow is formed when the sunlight falls on us, isn't it? Or on any other object. Similarly, cathode rays travel in a straight line, and that is why they cast the shadow of any solid objects on which they fall. This is the shadow I have marked. Okay. Third point is, cathode ray consists of particles, means tiny particles are there, as well as energy, and energy is in the form of that. Energy is present and the particles are also there. That is why the rays set a paddle wheel. If you put a paddle wheel here, a wheel is there, this wheel will start rotating. Due to the cathode rays, the paddle wheel is set into rotation. Why? Because cathode ray consists of the minute particles as well as the energy in it. And the last point is, cathode ray consists of negatively charged particles. The particles which are present in this cathode rays, they are negatively charged, and they are just like, we can say, when it keep an electrical field means, you know, or a magnetic field, if you keep it near the discharge tube, this end is the positive end, suppose this one is the negative end of the magnetic field or the electrical field. The cathode rays which are negatively charged, instead of going towards the anode, they will get deflected towards it. They will move towards this side. It means whenever we keep a magnetic or electric field, the cathode rays get deflected towards the positive end, towards the positive terminal of that magnetic field, not towards the negative end. Understood? So this is the fourth property, that cathode ray consists of negatively charged particles. When they are subjected to electrical field, they get deflected towards the positively charged plate. This is positively charged plate. So because it is negatively charged, these cathode rays will be attracted towards the positively charged plate, not towards the negatively charged plate. Because opposite charges will attract, not similar charges. Okay. And the last point, the fifth property of cathode rays, which is mentioned, number E, cathode rays ionize the gases. Ionize means to break the gases into their particles through which they travel, and they travel with the speed which is equal to that of the speed of light. Means speed of cathode rays is same like the speed of light. Okay. Now from the above properties, J.J. Thomson had assumed that or established that cathode ray is made up of negatively charged particles which are known as electrons. So indirectly he had discovered the electrons by discovering the cathode rays, because they show all the properties of electrons. So now next we will study some of the properties of electrons. What are the properties of electrons? I will try to list it here and see how it is similar to that of cathode rays, because it is this cathode ray is made up of electrons only. So first property of electrons are negatively charged particles. So first I am writing E. E means electron, and I am writing it as, now you can see how to denote these electrons. If what is the atomic number it has? Electrons from all sources, they have similar mass. Means the M, the mass which is present, mass of electrons is same. Whether you get it from anywhere, from all sources, same or equal amount of mass will be there. Second point is they are constituent of all atoms, because these electrons are present around the nucleus. They are revolving, so they are present in all the atoms. Second point you can write, present or part of atom. That is the second characteristics. First is the mass of electrons is same whether we obtain from different sources. Second is electron is a part of the atom. Third one is the mass of electron is equal to 1 by 1837 times the mass of a hydrogen atom. That is equal to 9.108 into 10 to the power 9.108 into 10 to the power minus 27 kg. So see, minus 28, not 27, 28 gram. So this is the mass of one electron. 1 by 1837 times mass of hydrogen atom. Either this one you can write, or you can write it as 9.108 into 10 to the power minus 28 gram. So less it is. It's almost negligible mass, you can say, very less. And the fourth point is an electron carries a unit negative charge. You know that the charge which is present on electron is negative charge. And next, the electrons are extremely small. Their radius is 1 into 10 to the power minus 15 meter. This is the radius of electrons. So electron is that fundamental particle which carry negative charge and has a mass equal to 1 by 1837 times the mass of one hydrogen atom. And how it is denoted? The electron, I have said, it is denoted as E. Then you can write minus 1 and on the top 0. This 0 indicates that what is the total, this minus 1 you know, 0 indicates the mass here. Okay, you can find that 0 indicates that it has no mass, and this minus 1 indicates that it has a negative charge. So this 0 is for mass. Alright, mass is 0 and the charge is minus 1, negatively charged. Okay, so we have completed up to electrons. Now next we have to study about discovery of protons. So hope you have understood this one. J.J. Thomson. Try to write it and draw this one also. And as homework you can do it, that explain the J.J. Thomson's model of an atom. Or no, you can write explain the J.J. Thomson's experiment of discovery of electrons. So 5 points are there. You can write those points. Then you can write the definition of atoms, definition of element, what is a discharge tube, what are the properties of electrons, and differences between Dalton's atomic theory, in the beginning I had done, and modern atomic theory. Then you can write who is known as the father of modern atomic theory. Okay, so this much only. In the next class we'll continue with the discovery of protons, properties of protons, discovery of neutrons. Okay, it's quite okay. So after watching the video you can write your name in the comments. Thank you.